Good.
Hello, my name is Robert Kosalski. I'm going to give a demonstration of flame retarding nylon for fiber applications. And we're going to do this using a flame retardant I invented called PNS for phosphorus nitrogen solution. It's PNS. And let me start by, here's a piece of the material which we grind up to put into polymer. And show you that this is a single component intermediate material. It does not require carbon or a glowing agent to do it. It's just one compound. And you see that we have a lot of intermescence. And in fact, you can peel this off and you see that you still have a lot of the flame retardant material underneath. And if you peel it further, you see that it didn't do anything to the rock. So it's and as far as I know, this is the only material that melts into the polymer, phosphorus nitrogen component. Now, this is a 16th inch thick nylon. And nylon actually doesn't burn readily because it forms drips, and the drips keeps the fire from starting. But that's also what makes nylon fabric exceedingly dangerous in a flame, because these drips, they will get on your skin and cause severe burns. And if we had actually applied a torch to this, then this nylon would take off. And nylon actually has an LOI of 19, which means it burns readily in air. But you wouldn't know it from the drifting behavior with this small flame. Now, let's see what happens when we take our nylon again. This time we've entered 20% of our flame retardant, the intumescent. And you're going to see that it actually starts to burn because we've greatly suppressed the dripping behavior by the intumescence. And let's let it catch on fire. And the reason it catches on fire readily is because it's not dripping. The intumescence stops the dripping. Now if we turn it over, we see that the flame is going to go out. And what is important here is that the intumescence is quite thick, in that it's caused the flame to go out. And if you make a fiber that is 10 microns in diameter, which is the normal diameter, the intumescence is greater than the thickness of the fiber. And so that you will forego the dripping part, which is so dangerous for protective apparel. And you have a flame retardant nylon fiber that will work quite well, especially if you make yarns where you have a lot of air embedded between the nylon fibrils that are 10 microns in diameter. So anyway, let me just say, making protective apparel is complex, but this is the key feature which will enable this to be a unique additive for making nylon fibers. And let me show you that we still maintain the properties that make this nylon, in that its toughness, and that it's still quite flexible, despite the fact that we've added 20% of the flame retardant. If there are any questions, my phone number is 610-368-6820. Thank you very much.